So far, we've been trying to integrate one polynomial over another, and up until now, we've taken care of cases where the degree of p is strictly less than the degree of q. So now in this video, we are going to try and tackle this scenario here, where the degree here is bigger than the degree of q here, bigger or equal to. Okay, so for example, if you look at this, the degree up here is 3, and the degree down here, remember, if you get this times this, you'll get x squared. That's the highest one. So the degree here is 2. So here we've got a scenario where the degree of the numerator is bigger than the degree of the denominator. So to do this, we would multiply this out here, so that will then give us this thing here. So rewrite this, well, multiply this out, and then that will then give you this. And the aim here is to try and rewrite this in this form here. So we'll because this thing here is bigger than the denominator here, you can get this divided by the denominator. That's going to give you some sort of whole number, in a way a whole number, in a way some sort of whole being here, and then some remainder here. So our aim here is to try and rewrite this in this form here. So for example, if you look at this here, 10 over 7, you can rewrite this as a 1 plus a remainder. So this is your remainder, and then over the original denominator. So looking back up here, if you look at this, this is bigger than this. So when you get this divided by this, you're going to get some sort of whole thing here, plus some sort of remainder here, and then the denominator. So it's a bit like this. You're going to get this divided by this. You're going to get a whole thing here, plus the remainder over the original denominator. So if we were to look at this here, get this divided by this, you're going to get some sort of whole thing here, and then remainder over the original denominator, So that's our aim. So for example, if you look at this here, we are going to attempt to get this divided by this. So we're going to get some whole thing here, plus some sort of remainder over the original denominator. And if you look at this, the degree of this here, the degree of this is 3. The degree of this here is 1. So here we've got a scenario where the degree of the numerator is higher than the degree of the denominator. So back in high school, get this divided by this. So here we've got a scenario where this is bigger than this. So this is us doing this over 5 here. So this is bigger than this. So we should get some whole thing here, and then some remainder here over the original denominator 5. So for example, so to do this back in high school, 7 divided by 5 without going over is 1. So now we would get 1 times 5, so that would be 5 here. Now get the whole thing, take away this whole thing here, so that would be 2, and then 3, 0, 2. And now look at this here, 23 divided by 5 without going over, so that would be 4. Now we would get 4 times this would be 20, and then now this would be 302. Now we would zoom into this. 30 divided by 5 without going over is a perfect 6. So now we would get 6 times this. That will give us 30, and so on here. That would then give us a remainder of 2. So now we can rewrite this as, hang on. So now we can rewrite this as this thing here, 1460 plus, well, remainder of 2 here, 2 over 5. So this thing here is the same as this. So So now we can use the same technique to do this. So now we're going to use the same technique to do this. So looking at this divided by this, so without going over, so hang on, 3x squared divided by 3x, so so that would be that, 3x cubed divided by 3x, so so the 3 will cancel out, so this here will be x squared. So hang on, this divided by this without going over would be x squared. So now we would get this times this here, so that will give us, so this times this here would be 3x squared, and then this times the 1 would be plus x squared, plus 1x squared. Now we would get this whole thing, take away this whole thing, so so that would be this, take away this would be hang on, let me just tidy this up, would be 0 here, and then this, take away this would be minus 6x squared, and then this, take away 0, well, blah blah blah, this would then give you this. And now now we would look at this divided by this without going over. So hang on, negative 6x squared divided by 3x here. So this divided by this here would be negative 2, and then this divided by this, that would be, so this divided by this without going over would be negative 2x, negative 2x. Okay, so bear with me. So now get this, now get this times this whole thing here. So that would be negative 6x, 6x squared, and then negative 2x, negative 2x. So now get this, take away this, so that would give us, bear with me, that would give us 12x, and then minus 3. Now looking at this, now this divided by this without going over, hang on, 12x divided by 3x, so this would be 4. So so it would be plus 4 here, but then now let's get this times this thing here, so that would be 12x plus 4. 12x plus 4, so that would be 12x plus 4. So now now get this, take away this, so that would give us minus 3, take away 4, that would give us minus 7. Okay, so our remainder is minus 7. So we can actually say, we can actually rewrite this thing as, hang on, so we can rewrite this thing here as this. The remainder is negative 7 over the original denominator, Okay, so if you look at this here, when you get this whole thing here divided by this, you will get this whole thing, and then remainder negative 7. So you can rewrite this. You can rewrite this as this. So when you come to integrate this dx, then that's the same as you doing this dx. And then now this is easy. And then now we've got a scenario where the degree of this is smaller than the degree of, so this is home territory. We've done this many times. So the point here is that we can reduce this to this by using long division. I will give you some more practice on long division, and then we will get back to our example from the start. Okay?